So let's look at the mixed Rossby gravity waves, free waves in a zonally varying flow. We just looked at the equatorial Rossby waves and saw that based on where the waves are originating and the varying back basic state can end up trapping the waves or letting them propagate. The key factor being the group velocity and the basic state and how they interact with each other. Mixed Rossby gravity waves, again, the only thing to remember is that d omega dk is always positive, so the group velocity is always eastward. So when you look at the basic state, that's what you have to remember. Going back to our ray path equation, dk dt is minus k du bar dx. U bar is again a function of x. So if you go into the negative stretching area where you have easterly winds and they are decreasing in the x direction, so you can see this what is described as backward accumulation or forward accumulation in the case of Rossby waves, where you have westerly westward group velocity meeting westerlies and getting trapped, which is forward accumulation because you're in the direction of the group velocity, whereas backward accumulation is when you have opposite flow trapping the energy, right? So mixed Rossby gravity waves, n is 1 in our dispersion relation. Looking again at frequencies, wave number in terms of zonal velocity dependence, depending on where you are releasing or where you are starting the wave. Point C, so your group velocity is eastward, the flow is westerly, so you're getting stretched, and then you are going to hit decreasing westerlies. Okay, so you are going to have trapped mixed Rossby gravity wave, so you cannot go in the other direction, so you cannot get longer, so you're stuck at this wave number where you're released, and to stay on the frequency line you only go towards smaller and smaller waves, which means the scales, larger and larger wave numbers, so the spatial scales get smaller and smaller, and they are trapped in the sense they cannot radiate energy too far away from where they started. I hope that's clear in the previous diagram as well. Looking at B, which is released in the easterly regime, so it's going to have easterlies stretching it, easterlies opposing the group velocity. So you have again a trapped wave, so again wave number cannot go below whatever this is here to stay on this frequency, and you head towards increasing wave numbers, become shorter scales, and you are trapped in the sense you cannot propagate too far out from the source region. Okay, whereas if you are in a different regime, you can create, or if you are originating at a different place, you can create a propagating mode. So you can see that this is now propagating between these, so it's released at wave number what is this, 1 2 3 4 5 or so, and it's on this frequency line of minus. So I think I forgot to mention something here which is actually critical. I should have been careful. Here we are allowing frequencies to be negative and wave numbers are positive. Remember in the previous dispersion diagram there were two conventions. One was where the waves traveling westward had negative longitudinal wave numbers, and eastward traveling waves had positive longitudinal wave numbers, and the frequency was always positive. We had also looked at the convention where you could keep the wave numbers positive and allow the frequency to be negative. It doesn't change the physics, it just changes the presentation. So we can see that here the zonal wave numbers are positive. but the frequencies are negative, so we have to be careful about that. So that's what we are doing here. So released at the peak of the easterlies here into the direction of decreasing easterlies to increasing westerlies, you produce a propagating mode. Okay, so that's also here. You can see that the wave numbers are getting smaller, the scales are getting larger for the same frequency, obviously, which means the information can be radiated far away because you have long scale waves. Okay, just understand that physics. Now let's look at the impact of longitudinal displacement of wave sources in a zonally varying flow. So we still have these zonally varying flows, and we are releasing equatorial Rossby waves, and next we will do mixed Rossby gravity waves of different wave number. Here -3, which is fairly long compared to -7, meridional mode 1, which with equivalent depth of 400, which was also assumed here. Okay, so is it mentioned here? Should have been mentioned. Nonetheless, some things are specified. Again, just focus on the physics. Changing the equivalent depth is just going to change the various speeds and so on. So depending on where you release it along the longitude in different background states, for this wave number, you can see that released here, it's going to head towards wave number -3 means it's going to have, it's a long wave, so it's going to have westward phase speed, and so you are facing easterly flow. Okay, so you're going to get stretched, and then you're going to hit the direction of stretching, which is going to change direction. So when you hit 0 here, you are immediately going to hit westerly flow with westward group velocity. So you are going to get trapped, and you're going to accumulate energy. So different wave paths, ray paths. So D released here is still going through the same thing. These are the number of days after being created, after the waves are created. So you can see that this one is going for longer, day 20 here, and then it's going to again hit this inflection point. Same for B released here. Whereas if you release down here in the real world, this is somewhere in the Indian Ocean, where you have easterly winds to start with, and you are going to have westward group velocity. So you're going to get to propagate after day 10, 20, 30, 40, and eventually you're going to come back to here. So you're going to make a complete circle around the globe before coming here. If you look at it in the phase space of zonal wave number and longitude, you can see that again we are only sticking here to positive wave numbers. We are switching these conventions just to make these figures more easier to understand. So B goes here, begins to increase in wave number or become shorter scale and get trapped. Shorter scale, longer wavelength, shorter space scale means the information is going to get trapped. Energy is going to get trapped, right? So C, D, and then A, starting here, is going to become a long wavelength, and then eventually come back and also head towards getting trapped. So you can look at other wave number 7, which behaves differently. So now the same location is going to give you very different behavior, because at this wave number you have eastward group velocity and you're in a westerly regime, whereas here you have westward group velocity in a westerly regime, and so on. So again, the impact of background flow is very critical, and we will see in an example that this becomes the most important thing even when we do a full nonlinear solution. So we'll see some model solutions where all the nonlinearities are included, and yet the trapping remains basically the same, other than that the nonlinearities allow for multiple modes. Here we are typically looking at a system by simplifying the modes and the wave numbers and so on. Okay, so the solution is more complicated, but the trapping information, the trapping characteristics are still the same because they are dominated in the tropical region by the background flow and the variation in the longitudinal variation of the background flow, which becomes critical when we look for real climate tropical dynamics in the following chapters.